Every time you open your refrigerator, you feel cold air coming from inside. But the refrigerator is not actually making cold. Instead, it is constantly moving heat out of the compartment and releasing that heat into the room. So how does a machine in your kitchen move heat from one place to another? To understand this, we need to follow a special fluid called refrigerant as it moves through the refrigerator. Once we follow this process, the reason your refrigerator stays cold becomes much easier to understand. A refrigerator is an appliance designed to keep food and other items at a low temperature. It does this by removing heat from the inside of the refrigerator and releasing that heat into the surrounding room. This is an important point because a refrigerator does not simply produce cold air. Instead, it uses electricity to operate a system that moves heat from one place to another. To understand how this happens, we need to look inside the refrigerator. A typical refrigerator contains several important components. These include the compressor, condenser, expansion device, evaporator, refrigerant, fan, thermostat or temperature control system, and electrical control components. Each part has a specific job, but they work together as one continuous system. The process begins with a substance called refrigerant. Refrigerant is a fluid selected because it can change between liquid and vapor under suitable pressures and temperatures. The refrigerant travels through a sealed circuit of pipes inside the refrigerator. It does not normally get used up during normal operation. Instead, it repeatedly moves through the same cycle. The first major component in this cycle is the compressor. The compressor is usually located at the lower rear section of the refrigerator. Its job is to take in refrigerant vapor and compress it. When the vapor is compressed, its pressure increases. Its temperature also increases, so the refrigerant leaves the compressor as a high-pressure, high-temperature vapor. From the compressor, the refrigerant moves toward the condenser. The condenser is designed to release heat from the refrigerant into the surrounding environment. This is why the back or bottom area of a refrigerator can feel warm when the refrigerator is operating. The hot refrigerant enters the condenser. As it moves through the condenser tubing, heat transfers from the refrigerant to the surrounding air. The refrigerant gradually loses heat. As it loses enough heat, it changes from a high-pressure vapor into a high-pressure liquid. The heat has not disappeared. It has been transferred from the refrigerant to the room. This is one of the most important parts of the refrigeration process. After leaving the condenser, a high-pressure liquid refrigerant reaches the expansion device. Depending on the refrigerator design, this may be a capillary tube or another type of expansion device. The expansion device creates a restriction in the refrigerant path. As the refrigerant passes through this restriction, its pressure drops significantly. This pressure drop changes the refrigerant's condition. The refrigerant becomes much colder and enters the next major component, the evaporator. The evaporator is located inside the refrigerator compartment or in a position where it can absorb heat from the refrigerated space. Now the main cooling process takes place. The cold refrigerant enters the evaporator. The air inside the refrigerator is warmer than the refrigerant. Heat therefore moves from the warmer air in food toward the colder refrigerant. The refrigerant absorbs this heat. As it absorbs heat, the refrigerant changes from a low-pressure liquid or liquid vapor mixture into a low-pressure vapor. This is why the inside of the refrigerator becomes cooler. The refrigerator is continuously removing heat from the compartment. A fan may help move air across the evaporator. The fan circulates the colder air through the refrigerator compartment and helps distribute the cooling more evenly. Some refrigerators use separate airflow paths for the refrigerator and freezer sections. The exact arrangement depends on the design of the appliance, but the basic principle remains the same. The evaporator absorbs heat. The refrigerant carries that heat away. The compressor then pulls the low-pressure refrigerant vapor back into the refrigeration cycle. The compressor compresses the vapor again. The refrigerant becomes hot and high pressure. It then travels through the condenser and releases heat into the room. After that, it passes through the expansion device. Its pressure drops. It becomes cold again. It enters the evaporator and absorbs more heat. Then the cycle repeats. This happens again and again while the refrigerator needs cooling. So we can follow the refrigerant through four major stages. Compressor, condenser, expansion device, evaporator. The compressor raises the refrigerant's pressure. The condenser releases heat. The expansion device lowers the refrigerant's pressure. And the evaporator absorbs heat from inside the refrigerator. Together, these four stages create the basic refrigeration cycle. But there is another important question. How does the refrigerator know when to run the cooling system and when to stop? This is where the temperature control system becomes important. A temperature sensor or thermostat monitors the temperature inside the refrigerator. When the temperature rises above the selected range, the control system allows the cooling system to operate. The compressor starts or continues running. The refrigeration cycle removes heat from the compartment. As the temperature falls back toward the selected range, the control system can stop the compressor. The refrigerator does not need to run continuously at full operation. It operates in cycles to maintain the desired temperature. When the compressor stops, cooling stops temporarily, but the temperature does not immediately rise. The insulation around the refrigerator slows the movement of heat from the warmer room into the colder compartment. The door seal also helps reduce unwanted warm air entering around the door. This is why keeping the refrigerator door closed helps it maintain its temperature. Every time the door opens, some cold air can escape and warmer room air can enter. The refrigeration system then has to remove that additional heat. The same basic process also explains the freezer. The freezer operates at a lower temperature than the refrigerator compartment. Its evaporator absorbs heat from the freezer space. The refrigerant carries that heat through the system and eventually releases it outside the appliance. This continuous removal of heat allows the freezer to remain cold enough to freeze water and store frozen food. Another important part of many refrigerators is the defrost system. When moist air enters the refrigerator or freezer, water vapor can freeze on cold surfaces. Over time, too much ice can reduce airflow and interfere with heat transfer. Modern refrigerators may therefore use an automatic defrost system. A control system can periodically activate a heater or another defrost method to remove accumulated ice from the evaporator area. The exact defrost method depends on the refrigerator design. The refrigerator also needs electricity to operate its electrical components. Electricity powers the compressor motor, fans, controls, lights, and other components depending on the model. The compressor is particularly important because the refrigeration cycle cannot continue without moving the refrigerant through the system. However, the compressor does not directly create the cooling effect by itself. Its main job is to compress and circulate the refrigerant. The cooling effect comes from the complete refrigeration cycle. This is why every major stage is important. If the compressor cannot operate, the refrigerant cannot circulate properly. If the condenser cannot release heat effectively, the system can become less efficient. If the expansion device is restricted, the refrigerant flow can be affected. If the evaporator cannot absorb heat properly, the refrigerator may not cool as expected. The system therefore depends on the correct operation of all its major components. Another useful thing to understand is why the outside of a refrigerator can feel warm. If the refrigerator is removing heat from inside, that heat has to go somewhere. The heat removed from the refrigerator compartment is carried by the refrigerant toward the condenser. The condenser releases that heat into the surrounding room. The compressor also adds heat to the refrigeration system because electrical energy is converted partly into heat during operation. As a result, the refrigerator can release more heat into the room than the amount of heat that was removed from the food compartment alone. This is why the area around the condenser and compressor can become warm. The refrigerator is not violating the basic rule of heat transfer. It is using energy to move heat from a colder area to a warmer surrounding environment. The same principle is used in air conditioning systems and heat pumps. The components and operating conditions can be different, but the basic idea of moving heat using a refrigeration cycle is similar. So let's put the entire process together. First, the compressor takes in low-pressure refrigerant vapor. It compresses the vapor and raises its pressure and temperature. The hot, high-pressure refrigerant then moves into the condenser. The condenser releases heat into the surrounding air. The refrigerant cools and changes into a high-pressure liquid. The liquid then passes through the expansion device. Its pressure drops. The refrigerant becomes much colder. It then enters the evaporator. Inside the evaporator, the refrigerant absorbs heat from the refrigerator compartment. As it absorbs heat, the refrigerant evaporates into a low-pressure vapor. The compressor takes that vapor and begins the cycle again. At the same time, fans can move air around the cold evaporator area, while the temperature control system determines when the compressor should operate. The insulation and door seals help slow heat entering the refrigerator. The defrost system helps control ice buildup in designs that require automatic defrosting. All of these parts work together to maintain the temperature inside the appliance.